So the question that everyone's going to ask is, how do I know every SQL statement? Other than waving a magic wand, MySQL is a little short in providing a total solution here at this point in time. You have some options as listed there. You can look at the slow query log, you can look at the process list and try and catch it in the act. I've done that on many sites, unfortunately. You can rely on the application to log every SQL statement, but if you remember the point back before where don't trust developers, that still applies to the application, because even on the most strictest site where they say we follow this standard religiously, we prefix every SQL statement from the module of the code that is executing against the database. There's no unauthorized SQL statements going into the database. And so 10 minutes of just capturing show process status every second and filtering out and go, what's this statement? Oh, that should be running on our slave. It should be running on our production server. Well, you know this is like locking your table for 80 seconds. So never rely on an application server to keep a copy of all the SQL statements. There is only one way to get every SQL statement, that's to get it from the database directly. Unfortunately, MySQL presently only provides one practical solution for that, and that is the general query log. And it's impractical for two reasons. One, you're a site where you want to remain uptime for as much as possible, but to use this query log, you have to turn it on and turn it off by restarting the server. So there's 2 server restarts just to use the general query log. MySQL has tried to address this in 5.1 with logging to tables, which I've not used. However, now I'm focused more on MySQL 5.1, I'll be looking at it more. But this can also be a performance impact. The other problem with the general query log is it logs every single SQL statement. So if your database server is doing 2,000 modified statements and 7,000 select statements per second, when you turn it on, A, it's going to slow down a lot, and B, your log file is going to grow quite a lot. And if you're a part-time DBA, or in this case, an application person who wants to look at the SQL statements and turns it on and forgets to turn it off, and then the disk fills up, and the system is a production system with slaves, but they have no monitoring, so they don't know why their site is actually down. They rely on users to tell them when it's down. These things can have a ripple effect, especially when it corrupts your replication. So really the only practical solution that I've used effectively generally when I go on site for a short period of time, and I say that because a lot of my work is firefighting, spending 2, 3, 4, 5 days with clients. So I don't have the luxury of educating people on, this is how we should write the code, this is how we should test the code. $50 for the person who had their phone ringing. So MySQL proxy is a good solution that allows you to at least get a better look and feel. There's been some discussions this week about it. It's been out for a year now. If you have a look at histogram.lua, it can give you some good information, give you some good insight as to what queries are running. Also, it can tell you how many times it's been executed, what's the maximum time it's been executed. Give you a breakdown of reads and writes against tables, which is more information than the general com status columns. And in a direct connect environment like a PHP or Perl, you can manage it simply by turning on firewall rules and turning it off. And you can implement proxy, and I've done this on a client, turn on MySQL proxy on a production server for 2 seconds. MySQL proxy can start up independently of an existing MySQL instance. You can test it, make sure it works. The client, after doing, of course, all this in a test environment, the client goes, okay, well, we'll accept if we have a hiccup for 2 seconds, that's okay. Turn on a firewall rule to redirect all traffic to the proxy port that was going to the MySQL port, and in 2 seconds turn it off. And gather 2 seconds worth of information about what SQL statements are happening. And on this particular client, the first time I did this, they were amazed at, oh, okay, this statement shouldn't even be running, let alone it was run 600 times. It's a practical way to use it. Now, it's not perfect because what happens is the Lewis script is attached to the connection. So when I said direct connection before with PHP and Perl, it's good because you get a connection. If you're using Java, this doesn't work. So what you need to do is you have to reset your Java connection pool. Now, most well-established organizations that have got Java applications out there will have a URL they can hit that just flushes the connection pool manager and re-gets the connections. Some people don't have that. If you don't, you should get one of those. And on that side note, if you want to make some change to the JDBC properties, and that's in a properties file, and it's embedded in your jar file, which you have to rebuild and deploy to make a change, for example, optimizing the connections, and then restart your entire production server, you should pull the properties file out. Sorry, this is a side tip, but I've seen this before as well. So with Java, it's a little bit more complicated, but it's also a matter of just looking what options exist. I don't have it in the slides, but I make a recommendation to every client that I go to. I'm going to be in trouble. All development environments and all test environments that are non-benchmark environments should run with the general query log on all the time, because at least educates the developers in looking at SQL statements. You should monitor every SQL statement with the explain to look at the query execution plan. You should time the queries, you should actually count how many rows are being affected, and you should monitor this over time because things change. Looking at the result set size is a really extreme thing, but that also can help in defining whether the distribution of your data is increasing. You need to start gathering this information and checking it. If you do an upgrade, and even a point release, you should be rerunning these things just to verify that things operate the way they were. Indexes. Back to the design thing, you need to understand and appreciate what indexes are, what the benefits there are, why they're good, why they're bad, and also you need to specifically understand the different types of indexes that exist in MySQL. The fact that you can have concatenated indexes, the fact that you have partial indexes is different, the fact that you can have a covering index depending on your query, and I've had arguments with large Oracle installations with 250 servers who are moving to MySQL where they will not allow a covering index because that wastes disk space. They don't understand the principle of improving the performance. You need to know whether you need full text indexes, which will affect the different types of approaches of storing the data. And MySQL presently doesn't presently have any function for function-based indexes. So indexes are important, but you need to know where to use them and what the benefits are. Sorry, I'm going to talk fast because I feel I'm running out of time. I talked earlier about creating temporary tables. Create temporary tables and file sort are things that happen in the MySQL kernel that take time, and they can affect the performance on your server. And if you can eliminate a using file sort from a query which is being executed hundreds of times a second by having an appropriate index, then it makes a huge impact on your server, just in terms of the processing time to execute the query. So these are two things you should be looking at when you look at the queries that you execute by your query execution plan. And those who went to Baron's explain talk would have got some help on that. Transactions. You should always design your system to support transactions. Self-plug, obviously, because we provide a transactional storage engine. But just as a principle, MySQL inherently allowed you to write code that wasn't transactional based, but you should always be designing and working for transactions. And the large websites that are out there nowadays, they're all using a transactional storage engine. Data integrity. I think I talked before about the fact that MySQL is very lax in creating warnings historically. There is SQL mode that you can define that ensures that data that goes into your database doesn't throw a warning, which is generally not kept, but actually throws an error. So when I was talking before about not null and enum and unsigned, previously when you would when those rules would be violated, you would just get a warning unless you were looking at your warnings. You wouldn't actually know that MySQL was internally changing the data that you were storing without telling you. And people can be quite shocked when they expect something and they don't get it. Particularly, for example, storing a value when they realise it's been truncated to the maximum value of the integer column. The query cache is important, I guess, for the luxury of time. I'm not going to talk about it. Also, there was another talk on it. But you should look at other types of query cache, and MySQL, depending on your architecture of the servers that you have, the sharding, the type of insert data that you have, the type of queries you execute, can really be a great benefit. You can see an extreme amount of performance improvement, providing that your SQL statements are, and this is actually how it works, but we'll skip over that,